Welcome back to the Explainer. Let's dive right into a high-stakes exam challenge about substation grounding today. Now, this is one of those questions that routinely trips up even seasoned electrical professionals. It's a fantastic test of how well you can actually read and apply the Canadian Electrical Code under pressure. So, let's break it down together, straight from the source. So, here's our scenario. We've got an outdoor 44 kV substation with a 200 millimeter ground surface covering layer, specifically 3/4 inch crushed stone. The big question is, what is the maximum burial depth of the station ground grid conductors from the finished grade? Are we looking at A, 150 millimeters, B, 600 millimeters, C, 750 millimeters, or D, 800 millimeters? Now, at first glance, you might be tempted to just grab one of those numbers from memory, or maybe start adding that 200 millimeters into the mix right away. But hold on, because there's a very clever trick hidden in here.
Section 1. Decoding the electrical jargon. Before we do any math, let's just make sure we're all on the same page. As you guys know, a 44 kV substation is a critical high-voltage node. And that ground grid beneath it? Well, that acts as a massive ground electrode system. It's an absolutely essential safety feature designed to safely dissipate fault currents. By limiting voltage rise, it keeps those step and touch voltages strictly within safe limits for anyone walking or standing nearby.
Moving on to Section 2. Visualizing the ground grid.
It really helps to picture how this physically works. The station ground grid conductor, which, by the way, must be a minimum number 2 OAWG bare copper wire, essentially forms a continuous loop right around the structural equipment, like your oil circuit reclosers. If a fault happens, this continuous loop is what ensures all the non-current carrying metal parts and the nearby earth stay at the exact same electrical potential. That's what protects anyone in the vicinity from a potentially lethal shock.
To actually solve our puzzle, though, the golden ticket is found in Rule 36-302, Subrule 1, Item B of the Canadian Electrical Code Handbook. The rule explicitly states that the ground rods must be interconnected by ground grid conductors buried to a, and I quote, maximum depth of 600 millimeters below the rough station grade and a minimum depth of 150 millimeters below the finished station grade. You've got to read that carefully because it is literally packed with specific spatial requirements that we need to untangle.
Which brings us nicely to Section 3, rough versus finished grade.
So what's the difference? Just think of the rough station grade as the raw, excavated earth level. It's the dirt. The finished station grade, on the other hand, is the final top level you actually walk on. In our specific challenge scenario, this finished grade is made up of that crushed stone layer we talked about. The code relies on these two distinct reference points to dictate exactly where that grounding grid needs to sit beneath the surface.
All right, Section 4, navigating the math trap.
Okay, here's where people get tripped up. The original question throws a 200 millimeter crushed stone covering at us. But here's the secret. That 200 millimeters is a complete distractor. Rule 36-302 honestly doesn't care if the stone is specifically 200 millimeters thick when it comes to determining the maximum allowable depth. Instead, the code bases the maximum burial depth from the finished grade on a set formula. First, you take the code's mandated maximum depth from the rough grade, which is 600 millimeters. Then you simply add the code's mandated minimum depth from the finished grade, which is 150 millimeters. The code intrinsically bakes that 150 millimeter surface layer into its max depth calculation, regardless of how much extra stone you might decide to pile on top of that minimum.
And finally, Section 5, the final answer.
Doing that simple addition overrides the distractor completely and gives us our final solution. 600 millimeters below the rough station grade, plus the minimum 150 millimeters below the finished station grade equals exactly 750 millimeters. So, circling back to our original options, 750 millimeters is the mathematically correct maximum burial depth from the finished grade. Option C is your winner. By just ignoring that 200 millimeter distractor and strictly following the baseline safety parameters set by Rule 36-302, you land perfectly at the safe, code-compliant maximum depth.
As we wrap up this explainer, I do want to leave you with something to chew on. We know the code strictly dictates these depths to manage fault currents, right? But how might environmental changes, like say a sudden drop in soil moisture during a severe drought, or the ground freezing solid in the dead of winter, completely alter the actual safety calculations of the very grid we just measured? The physical depths of the copper wire are fixed at 750 millimeters for sure, but the earth around it? That's constantly changing. Definitely some food for thought. Thanks for joining me on this deep dive, and as always, keep that curiosity sparked. Catch you next time.
For more sample question, follow us.